what might very well be a historic guest on the stage of Microsoft Reactor. Google Fonts' very own Tobias Kunisch, their design lead. Please welcome him.
Hi everyone, look at that picture of me. Let me try to see if I can make this work. Do I need to switch inputs on this one somehow? No? Here we are. All right. All right, so I promise you this one will be AI and fairly code-free. We're going to switch gears a little bit. We're going to talk about fonts, and specifically about how fonts are software, especially these days. My name is Tobias. I have been with a company called Google for the last 13 years. I lead the design team of the Google Fonts team. I actually co-founded the team about 12 years ago as like one of those 20% projects that they let you do at Google. So let's dive in. I'm going to try to be real quick so everyone can get back to the beer outside. I want to introduce you to this gentleman. His name is Aldus Manutius. He lived in the 15th and 16th century, and he's known for many things, like one of them being he ran a printing company. At this printing company, he invented a format of books that eventually became pocketbooks, which got a lot more people into reading. Another thing that he did is he commissioned his type designer called Griffo to cut the first cursive font. There were no cursive fonts before. This was sort of his idea to replicate handwriting in printing. And back then, when you had the idea to create a new style for a font, you had to cast it in metal, right? Like fonts were sets of little metal pieces containing several pieces of the same letter, so you could print them into a page, set them in a page, and use them in printing. So to create a cursive font, you had to create an extra set of metal that was this cursive version of the other set of metal that you already had in regular. And another thing that happened in printing back then, you had to have another extra set of metal for each size that you printed in, right? So this is an example of different lowercase a's ranging from very small 4-point to very large 72-point. They're all scaled to the same size to demonstrate how the shape of this lowercase a was actually a little different between small, medium, and large. This is called optical size and was there to optimize your reading, your perception of the A and small and large to be basically the same. And for it to be the same, it had to be different to be perceived by the human eye as the same. So this still persists in software, right? Like we have a different font file for every regular, italic, thin italic, like any combination. And you have the same again for condensed. At the bottom here, I'm showing Roboto in Fontbook on a macOS device. This also still persists in text editors, like here, Microsoft Word, showing Calibri and the different cuts, right? This is the same thing, light, italic, regular. It's the same thing as back in the day when, there were different sets of metal. So the software that we use today we use to create fonts is based on the OpenType standard. That's from 1996. There was a collaboration between Adobe and Microsoft. Back then there were actually different standards that were competing. Apple had one, there were others. Eventually everyone aligned on the OpenType standard. And in 2016, Google, Apple, Adobe, and Microsoft collaborates on an extension to the OpenType format, where it's called the OpenType font variations, more commonly known as variable fonts. And variable fonts make it possible to have all these stylistic variations, all your condensed and italics and all the other styles in one font file. And this finally makes it possible to use fonts programmatically as you would with real software and manipulate them at runtime. So what's good about that? We usually talk about like 3 different sets of benefits that you get from that. We talk about compression, text finesse, and expression. So let's look into those. So the compression part is all about like smaller file sizes. Now you have one file size, one variable font that you need to use in your website or in your project or in your app. That's a little bigger than a regular font file. But with regular fonts, you need several of those files. And if you use 2 or more styles from a font, and the corresponding font files, you get a bigger file size than you would get from a variable font. So there's, that's the compression aspect. The finesse comes in with like the things you can do with it and how you can optimize your typography. So this is showing what's called the weight axes. So these different features like weight and like all the other styles that you can package into a variable font file are called variable axes. Because now you can create a range, in this case, weight from 100 to 1,000. These are very random numbers. They're from OS2 times, but a weight 1 is very, very thin, a weight 1,000 is very, very thick, and now you can extrapolate between all those weights. So you can basically just pick any. You can pick weight 369, and you can access that. And you can access and you can change the weight during runtime to create these animations. This is the width axis that usually ranges from 25 to something like 150. Like it's up to every font designer to define their own ranges and what they want them to do. But this is a very nice way to create condensed type or very wide type or anything in between. So I'm going to switch to this tool over here. We built a little demo. The material DevRel team built that for us. We recently introduced a new version of Roboto, Roboto Serif, which is basically a very similar typeface as Roboto is, which you might know from Android devices, just with serifs. And this is here to demonstrate you the width and the weight axis. And you can see down here, I hope this isn't too small, there are new CSS rules that were introduced with variable fonts that you can use to manipulate these axes. So basically, font variation settings is what you use, and you just address the name of the variable axis that you want to manipulate. And then you can basically set any value on this axis to create these different styles. Okay, going back to the slideshow. So what I showed you earlier with the different letter shapes designed based on the size, this is now also possible, just like within one font file. And a variable font that uses optical size, as it's called, can automatically adjust the shape of the letter based on the size it's used in. So on the left, you see this lowercase a with optical size, and at larger sizes, the strokes are thinner, because at larger sizes you don't need chunky strokes like you see on the right. On the right is the same thing without the optical size, which just scales up. So it looks very chunky and very heavy. The nice thing about optical size is that it's supported by all modern browsers. There's one called IE that doesn't support it, but I don't think anyone's using that. All modern browsers don't only understand optical sizing, but also apply it automatically. So if you have a font that has optical size built in, it basically will automatically pick the right letter shape for the size you use the font in. I'm not going to show you this video, but I'm going to show you the website it's based on, which is a little website, a little demo website that we built for Roboto Serif, to show you this in another way. So this is width, right? So you can now go very condensed with your text, very wide. We've built optical size in here, like the text scales with it, as makes sense. This is weight. And what's interesting about weight, usually, and you will have seen this, if you make a font very bold using a high weight value, the text reflows, right? Because like all the metrics adjust accordingly. A lot of variable fonts also have a feature called grade, which does the same thing as weight, it just doesn't change the metrics. So for example, if you hover over a button and you want that to become bold to signify that you're like hovering over it, you can now do that without, changing the label length and, adjusting the padding and all that. So I find that very useful. Going back to the presentation. So I just showed you Roboto Flex. We also have a new variable version of Roboto. It's called Roboto. I showed you Roboto Serif. Now I'm showing you Roboto Flex, which is the new super variable version of Roboto that has additional axes that we call parametric axes that you can use to fine-tune like really heavily the type that you're using. I'm just skipping into this video to show you a little bit of like what can be done with those parametric axes without showing you the whole video because we're running short of time a little bit. But you sort of get the idea. And if I change over to this site, this is fonts.google.com, you can try all this out. So if you look at this lowercase, if you look at the lowercase g or the lowercase y, you can change the length of the descenders. Grade is here, what I showed you, like the weight without the metrics change. You can change the width of the counters. You can change the height of the ascenders if you look at the F, for example, and so on. So you can use this to really fine-tune your typography. One very nice application of that is like, I think at this point we all know that you shouldn't justify text on the web because it looks awful. It creates all those holes. Like with a font with parametric axes, you can still do that because you can have the font adjust to fill that space and just create good typography regardless. The same is possible for icons. The Google Fonts team also maintains the material design icon set. We updated that to all be variable fonts now. We call them material symbols. And those have weight and grade and optical size just the same, which can be very useful. Like if you go to fonts.google.com/icons, you can try them all out. There are sliders for everything, and you can download the exact icon that you need for your design. So that was the finesse part. And I want to touch on the express part also, because while finesse is, all about optimizing your typography in your project, the finesse part is, really about like big expression things that you can do with these fonts. Any type designer can come up with any variable axes that can build in there into their project. So one font family that we released recently is the Tilt fonts. And Tilt is inspired by shop signs, those neon shop signs that say open or closed or, are, around, I don't know, a lamppost or whatever. This font has like all these axes built in to replicate this and, to make them feel three-dimensional. I'm just gonna stay in this mode. Another typeface that I wanted to show you is called Kablamo by Vectrotype. This is the website we built for it. And this font has an axis called the morph axis. That's what makes all these like little features, the holes in the K, little strokes running around. Like with the morph axis, you can manipulate those. And what we're doing here is basically just running a JavaScript that's changing the value assigned to the morph axis. So there's very neat things that you can do with this, right? Another font that I'm really quite excited about is called Chantal Sons. This was a collaboration we had with an artist called Chantal Martin. She's based in New York, originally from Britain. And her art incorporates a lot of her own handwriting. So we worked with her and a foundry called Aerotype to create a handwriting font that's a variable font. You're seeing animated here. There's also a Cyrillic version that we worked on. And the axes, the axes applied here are called bounce and imperfection. The bounce axis is so that like the letters don't all sit on the same baseline, because if you write, I'm sure you don't place like the letters all in the same line each time you write a letter. So with the bounce axis, you just like create that sort of like, bounce effect in the font, and the imperfection makes it so not every letter is like the exact same, as you also wouldn't do it when you write with your own hand. Another font that's gone through the media a little bit recently is the climate crisis font. That font has a year axis, and you can use that to simulate the melting polar caps in the design of the letter shapes. So the axis ranges from 1979 to 2050, so like demonstrating the projected impact of the climate crisis. And then there's another new standard called color fonts. What you're seeing here is a variable color font. It's called Nabla, something that we worked on with a few Dutch type designers recently. Color fonts are very interesting. We originally invested in the standard because we wanted to find a good solution for the Nodo emoji set that's used on Android devices. And all emoji that you see on Android devices now are actually color fonts. And we use that same technology to create like this demo font that has all these gradients and this sort of isomorphic effect. And what's interesting about these color fonts, because you might say, I can change the font color any font, but they have gradients and they have these color palettes built in, so you can basically with your CSS just like choose which color palette you want it to show. You can, change your color palette when user changes to night mode, for example. And you can also use CSS to manipulate the colors just by hand. You can assign different values. So just to show you this one, we're at 7:45. We're doing good. So I can make this bigger. So if you see here, these are the axes that I manipulate. And you can do all that in your web project or in your app, just manipulating these values. All right, that was quick. That's all I had. Here are a few links for you. All of this on fonts.google.com. The demo site that I showed you is on the second link. We have a lot of articles about these typefaces on material.io/blog. And in addition, there's a really nice code lab on developers.google.com. It's called Migrating to Variable Fonts, which gives you sort of like a step-by-step guide how you can switch over and make use of variable fonts. And with that, thank you very much.
Thank you so much, Tobias. I'm going to be very liberal with my own prerogative to ask a question. You said basically this is all about creating good typography, which in my head means readability. There can be more aspects to it, I'm sure, but we often see that users are exaggerating even the very basic possibilities of manipulating text and fonts that they currently have. How do we enable them? How do we teach them to handle this responsibly to remain readable and to be actually useful?
Right. So readability is a very deep topic, right, and one that we think about a lot. There are several dimensions to it, right? Like one is like there are typefaces that are known to be more readable and some are less readable, right? Actually, a lot of people make a lot of jokes about Comic Sans, but Comic Sans is actually a very readable typeface, especially for
Google one as well.
No, Lobster is another very readable typeface. So that's one thing, right? And there's like things to know about like finding a good typeface that emphasizes readability. Another one is, you just have to be a little knowledgeable about how you set your type, right? Like what I showed you, like especially Roboto Flex with all those crazy options, like you can make very good typography with it, or you can also make very bad typography with it, right? Like if I give you a saxophone, you can either make very good music with it or you can make terrible music. You will make terrible music. Me too, but some people are awesome with it. So, it all depends a little bit. Like you can't all do it like with, one typeface. There are typefaces that make use, I'm not wearing my reading glasses, that make use of variable fonts to increase readability for dyslexic readers, for example. One is called Lexend. And it has an axis called hyperextension. So what you see on the right here, you see the width of this word vary between those different lines. And this is actually to counter an effect for that dyslexic readers experience called crowding, where like letters run into each other. So Lexend is designed so that people can use this axis to find the right width of the letters and the words to avoid their sense of crowding. That's different for everyone. So we think that variable fonts can help with people finding the right setting for them to create the readability that they need. Because there's a lot of recent research that shows that if you test with a group of participants, the same font can be perceived as the most readable and the least readable by groups of people, right? Like we're working with the University of Florida on the Readability Consortium that also includes Adobe, and they have like really interesting studies that show that, like Roboto, for example, like in a test group, 7 people said it's the most readable of like a bunch of fonts that they were shown, and another group said it's the least readable. So I think it's all about like what you personally need and enabling your users to pick the one that helps them.
Thanks. After that very fulfilling response, any questions from the audience? Yes, amazing. Sorry, these guys were first, but I'll get to you, I promise.
For the colorful 3D font that you had at the end, right? You played with the depth, and it looked like the depth was exactly visually stopping at the next character. Can they overlap? How does that work with variable fonts? I was just like, is that possible? In the fake 3D space, I assume?
Yeah, no, I know what you mean. So, yeah, they stop exactly right there. So, I mean, there are good fonts and there are bad fonts, right? Like what you will find on, some websites on the internet that, provide a lot of like free font that have like, no information about license. Those are fonts that are quickly made that aren't really like, made with quality in mind. So with fonts created by thoughtful type designers, like a lot of that can be, sort of like prevented from the start. We think this is a really good font. However, like you can manipulate the letter spacing here, right? You can use CSS to pull this R and this E together, and then they will run into each other, right? So there's like, great power, great responsibility, right? You can really mess it up, but you can really do really great things also.
Thanks.
Is it just a display, or is there also some dithering going on? It might be just a screen, right?
I think that might just be the screen.
Shame.
Okay.
There's another question.
Yeah, we had him first. Beg your pardon, I'll be with you in a couple of seconds.
So these dynamical Google fonts, is every font an individual project done by Google, or do you guys have some kind of platform or some kind of software tool that you use to create those dynamic fonts?
So this is a shared standard by the industry, right? Like the variable font standard has been created by a working group that comprises Apple, Adobe, Microsoft, and Google. It's an open standard. It's documented on the Microsoft typography website. So anyone can create a variable font. The ones that I showed you weren't all created by us. Like Roboto Serif and Roboto Flex were, that's work that we commissioned. The climate crisis font, for example, is just an open source font that we had contributed to our library.
We had one more. That was you.
Hi. Thanks for the great talk. How do these fonts get distributed? Like only TTF or also like WOF2, or how does this apply to that?
So it depends how you choose to use them, right? Like you can, like these are all open source, right? So you can go to GitHub and download them. You can also choose to go to fonts.google.com and download them, or you can choose to use our API. So picking Roboto, for example, which just provides like an embed link, and then you can, that will generate the right code for you, like the add font face rules, and give you the CSS. And when you use our API, we do our best to optimize for the browser that your client is using. So most of the time that will be WAF2. There's some browsers that don't understand WAF2, and then we optimize it differently for them.
If there are no other questions, I would have one.